Hi, welcome to the video on limiting reactant and theoretical yield. This video is designed to go with this packet, Unit 5 Stoichiometry Limiting Reactant Theoretical Yield packet. So if you need to take a moment to grab that, please do so now. Just to quickly recap, told you in the beginning of these sets of lessons that you guys actually know how to solve these problems, and we use this scenario to prove it. You want to make 30 cupcakes for the students in your class, including yourself, and this is what you have. And the two questions you're asking yourself is, do you have enough ingredients, and what's the maximum number of cupcakes? And you were able to solve that problem, and the same thinking that you use to solve that problem is the same thinking you can use to solve a limiting reactant or theoretical yield problem. So what are the key pieces of information? One is the balanced equation. That's sort of like the recipe. So you see in this recipe here where you have 1 cup of water and 1 stick of butter and 3 eggs, and that will give you 12 cupcakes. Well, the reason why a recipe is important is because it tells you the ratio of reactants, which are sort of like your ingredients, and the ratio of products, which is like your food. So that'll help you to answer these sort of questions at the bottom. Now, in terms of answering this question, the first question is, do you have enough ingredients? Well, you determined that you didn't. You determined that you were going to run out of the boxes of cake mix and the eggs. And so the cake mix and the eggs will count as your limiting reactants because those are the ingredients or the reactants that we run out of first. The second question is, what's the maximum number of cupcakes you can make? You found out you can make 24 cupcakes from what you have. And this would be your theoretical yield. It's the maximum amount of product you can make from what you have. Now, will you actually make 24 cupcakes? Maybe not. Maybe you didn't scrape well enough to get all the mix out. So this just tells you this is the most you could possibly make if everything goes well. In that packet, that sort of summarizes that same information. So if you haven't read that first page of the packet, do so now. And then when you press play again, we're going to go on to the first example for limiting reactant and reagent. All right, here is the limiting reactant example that's at the top. It says if you have 14 moles of N2 and 28 moles of H2, which reactant is the limiting reactant? Before we get started, one thing you may notice about this problem, unlike the mole to moles, is that you're given two values. You're given moles of N2 and moles of H2. And what I mean by given, you have numbers for both of these. So this makes it a little bit confusing, right? That's why the very first step is for you to choose one of these reactants, either N2 or H2, to be your given, and you'll use the numbers here, and the other to be your find. So for example, I could choose N2 to be my given. So I would say I'm given 14 moles of N2, and I'm trying to find how many moles of H2. Or I could say I'm given the 28 moles of H2, and I'm trying to find how many moles of N2. It doesn't matter which one you choose to do. So let's just stick with the first situation where I'll use the 14 moles of N2 as my given and the X moles of H2 as my find. Now I'm going to turn this into a mole to mole problem by simply asking myself this question that is boxed here in this pink box. So this sentence frame is really super helpful. I'm asking myself, well, how many moles of H2 do I need to completely use up the 14 moles of N2? Why is that important? Because once I know how much H2 I need, I can go back and compare it to how much I actually have, which is written in the problem. And then from there, I can figure out if H2 is going to run out, or if I have it in excess, or if I have just enough. So writing this may seem like an extra step, but if you're not writing it down, you should be asking yourself that each time. And then towards the end, once you get super comfortable with it, you won't even need this step. But for right now, I'm going to ask you to do it. Now we're moving on to step 3. This is a mole-to-mole problem, so we're going to do like we've done before. We have our given and find, which is these two pieces of information, and we're going to use them to set up in our first fraction. So I just chose to put the 14 moles of N2 on top and the X moles of H2 on the bottom. The second fraction, do you remember where this information comes from? That's right, it comes from the balanced equation. So looking at my first fraction, I have N2 on the top. That means I need to have N2 on the top of the second fraction. And I just go and look and find it in the balanced equation. And there goes N2 right there. and the coefficient in front is 1, so I write that as 1 mole of N2. I do the same thing for H2, which is in the bottom of that first fraction. So I got to go ahead and find it in the balance equation, and there it goes. And so then I use the coefficient in front of it, 3 moles of H2. Once I have my two fractions set up, I can cross multiply and solve. Here's my work for the cross multiplication, so you can check it out. And once I cross multiply, I find that I need 42 moles of H2. Okay, so we've completed step 3 now, which is answering this question, how many moles of H2 we need. Let's move on now to step 4. We know how much we need, right? So what I solve for is, again, super duper important. What I solve for is how much I actually need. But how much do I have? How much do I actually have? For that, I have to go back up here. And I got to find H2, in the problem. And it says I have 28 moles of H2. So based on the fact that I have 28 moles, but I need 42, do you think H2 will be the limiting or excess reagent? So that's right, H2 will be your limiting, and that's because you need 42, but you only have 28. So you can say it's because I need more than I have, or you can say H2 is your limiting because you have less than you need. In either case, you know you're going to run out of it first. So your next steps is to try CFU 1 and 2 on page 2. And if you get stuck, you want to identify what step is challenging, so you can circle the step or star it. Or maybe as you're going along, there are questions that you have that get you stuck. Write down those questions so that way in class you'll be prepared to get those questions addressed. We're now going to move on to theoretical yield. So at this point, I expected you to have read the information on theoretical yield, which is on page 3, which is the same page as the example we'll be doing. All right, in the example, there is a slight error. So it should read, if you have 6 moles of N2 and 21 moles of H2, what is the theoretical yield of NH3? So you want to make that correction here. Okay, take a look at your first step for this problem. The first step is limiting reactant, which is the process that we just went through before. Notice that we're given the amounts of both of our reactants, so 6 moles of N2 and 21 moles of H2. So that means that we're going to have to choose which one we want to be our given and find. And once we do that, and I'll choose the 6 moles of N2 to be my given and H2 to be the thing I'm trying to find, then we can use this sentence frame to figure out how many moles of H2 do I need to completely use up 6 moles of N2. Okay, we can set it up to solve. This information came from this question, right? And this information came from the balanced equation. And we've seen that multiple times. Here is the work I used to solve by cross multiplying. And this again is key. What I solve for is the moles of H2 I need. So this number is the amount I need. Where would I find the amount that I actually have? That's right, back in the problem. So I have how many moles of H2? 21. So let's think about that. Am I going to run out of H2 or is it in excess? So I only need 18, but I have 21. So H2 is in excess. That means that N2 is the limiting. If one reactant is excess, the other is your limiting. Okay, that was just the first step for a theoretical yield problem, is limiting reactant. Now what we're going to do for the second step is we're going to use our limiting reactant, which is N2, to figure out the theoretical yield. So for this, we'll use this sentence frame. How many moles of the product, in which case is NH3, can I make from the 6 moles of N2? All right, so this is a simple mole-to-mole problem. I'm going to take the information from this question to figure that out. Notice that I am not using 6 moles here because I use it up there. The only reason why I'm using 6 moles here is because I determined that the N2 was my limiting reactant. If H2 was my limiting reactant, I would use 21 moles of H2. So that's important to know. So I got this information from, or I chose to use 6 moles of N2 here because N2 is my limiting. So what I'm trying to find in this case is the moles of NH3. So now for my X moles, I put NH3. I get this information from the balanced equation. So it's a 1-to-2 ratio there, and I can cross multiply and solve. Okay, so what I solve for is the moles of NH3, and that tells me that for these two ingredients, 6 moles of N2 and 21 moles of H2, the maximum amount of NH3 I can make is 12 moles. And so I could say theoretical yield of NH3 is 12 moles because I can make 12 moles from 6 moles of my limiting reactant. Remember, the limiting reactant runs out first, so I can't make more than what I have. Your next step is to try CFUs 3 to 5 on the next few pages. And again, identify any questions or steps that are challenging. Just to quickly summarize what's going on here. For both limiting reactant and theoretical yield problems, they're different than mole-to-mole because you're given the amounts of 2 reactants. When you're solving for a limiting reactant, because you're given the amount of 2 of them, you have to choose one to be the given and the other one you're going to solve for as your find. And it doesn't matter which one you choose. The other key thing is once you solve for your find, it's important to know that that number is what you need. You have to go back to the problem to find out how much you actually have and then compare them. And finally, if it's a theoretical yield problem, you're going to use your limiting, whatever you determine to be your limiting, to help you find your theoretical yield. Hope you found this video helpful. Have a quality day.